Welcome back, everyone. So this is a kind of continuation of, the keynote kickoff this morning. So it's basically taking you right from where I left you off after my 15 minutes. And fighting a little with Google Slides, getting the latest slide deck here over the wireless. We seem to be ready. So I labeled this one, or relabeled this one, Spring Framework 6 infrastructure themes, because it's meant to complement the other sessions that you can see at this conference. Complementing the keynote, of course, complementing quite a few other sessions, most of them coming from actual core framework team members. The focus of this session is on generational infrastructure themes that are really driving not only the 6.0 release, but the entire generation that follows. And it's mostly topics that, at least from the perspective that I'm applying here, are not covered elsewhere. So I'm trying not to duplicate too much content featured in other sessions. All right, to warm up. As you know from this morning, this is where we are. Just a reminder. We have a generation of the core framework, Spring Framework 5.3x. It's the foundation for the Boot 2.x generation, with the Spring Boot 2.7 release being the last planned feature release on that basis. So Spring Boot 2.7.x is going to be based on Spring Framework 5.3x. According to the current planning, there won't be a Spring Boot 2.8 or 2.9 anymore. The 5.3x line is long-lived already. It's been the basis for a few boot feature releases already. The baseline is well known. More interesting are the upper ranges. This covers the JDK up until 17 in terms of official support, the latest LTS generation. Effectively, it actually covers the JDK up until JDK 19 in terms of bytecode compatibility. In the Java EE space, maybe even more important note, we are based on the traditional JavaX arrangement. This means Java EE8 is the end of the story. You can use Java EE8 providers here with Spring Framework 5.3x and the corresponding boot releases, but you can't upgrade beyond them because of this aforementioned breaking change, where in Java EE9, the Jakarta namespace really forces the product providers to do a separate generation that is based on the Jakarta APIs. On a related note, Spring Framework 5.3x has a lot of heritage from more like a more traditional Java server perspective. It still aims to be compatible and sort of aligned with application server deployments mostly. It got adapted, repurposed for modernized deployment arrangement, of course, but it still carries application server compatibility, structural compatibility forward from that generation. A key theme in Spring Framework 5, of course, was the introduction of reactive programming. So we also have a certain duality that we introduced back then between imperative and reactive programming models. And it really took a number of years for us and for everyone, for the community, I'm sure for plenty of you, to figure out how we're dealing with this. Are we doing more traditional style, servlet-based web applications? Are we using reactive endpoints in specific places or in, for an entire service, for an entire application? We learned a lot of lessons along the way. And turns out there's actually new inspiration waiting to be uncovered. So fast forwarding basically to where we were with Spring Framework 6, we have the opportunity to lay the groundwork for a new generation of the framework that is really meant for literally 2023 and beyond. It's a very forward-looking perspective that we're taking here. The JDK 17 baseline, we explored that a little this morning already, is an indication of that. It's a strong signal we're sending, and there's also strong technical merit following from it, that we can internally be based on JDK 17 facilities, conventions, and APIs. The Jakarta namespace, it's not immediately connected to it, but goes along with it. We see this as an easier step to take, a major generational upgrade to go through, not several. So the JDK baseline upgrade goes along with the introduction of this breaking point in the Jakarta EE space, where only products based on the Jakarta namespace are supported going forward. So Tomcat 10, JD 11, Hibernate 6. This is what we're talking about here. You need to be at least at that level, and you're kind of buying into the further evolution of those providers going forward. And they are only going to be available to you to be consumed through the Jakarta namespace, Jakarta.servlet, Jakarta.persistence, Jakarta.validation. We also covered the observability initiative this morning, and won't go back into it. That's also a more generational topic, where we're kind of exploring the needs across the portfolio. And we'll be taking a lot of feedback on that, I'm sure, as we progress. Now, for the focus of this session, let's start with a bit of a more architectural perspective on the AOT topic. We'll dive into the platform module system topic. That's the JDK module system, where we are exploring our alignment with that module system. It's an opt-in arrangement, so by no means am I going to spend a lot of time kind of diving into the use cases for the module system. This is a choice that you're making in your scenarios, in your systems, in your applications. It's about the framework enabling certain usage models, certain deployment models, certain architectural models from the ground up. And last but not least, I've just actually rather recently, I put the virtual threads topic onto the plate here. This is Project Bloom, the preview that comes in JDK 19. This, at least potentially, has huge impact on the trade-offs, the choices that we're making in architecting server-side Java systems. I'm saying potential because it's not yet fully explored what that potential really is and how far the Java ecosystem will have to sort of a little adapt itself towards unlocking that potential. But nonetheless, it is on the immediate horizon. It's in JDK 19 in the early access builds already. We'll all have it, if we want it, in preview form in September onwards in JDK 19. And there's at least a chance that it will go out of preview into production mode not that long after. All right, so these are kind of three, also a bit of a personal selection of infrastructure topics here. Let's get started. Just a reminder, we're working towards a November 2022 timeline. So a visual reminder that the Loom release actually comes, the preview release comes 2 months before. And even more important reminder that at the end of this arrow, we already have the next long-term support release coming up with JDK 21. It's not every three years, it's every 2 years in the recently adapted cadence. So in terms of enterprise readiness, in terms of production environments that we expect to encounter, Spring Framework 6 is based on kind of the JDK 17 long-term support baseline, but it's already very much anticipating the JDK where it will be in 21 as the next LTS release. Because if you do the math, that's less than a year after our GA. Chances are a lot of people are going to adopt the Spring Framework 6 and Spring Boot 3 generation at a time when they will already have JDK 21 LTS just about available to them. All right. With that said, a few thoughts on the AOT topic. This is coming up in several sessions at this conference, not least of it all, of course, in the part of the keynote this morning, and in a dedicated session that Brian and Stefan will be doing tomorrow. So I'll basically add a certain perspective to this. It's not the first time that we are considering build time preprocessing. It's just a very first class concept now, and a much more wholesale attempt to it. It's in previous incarnations, we've had little tools like the Spring Context Indexer, which would basically perform a sort of class path scan at build time and produce a little file that enumerates the classes that match. And on startup, we would take that pre-computed sort of index instead of performing a runtime class path scan. But this already goes right into the territory that we're talking about here. We've only had those little pieces before. Certain things you could do that you could do in your build or that you could architect for, so that the startup of your Spring application, context specifically, would be faster, or would just have less discovery to perform and less loading to perform when it kicks in. In Spring Framework 6, with the ahead of time topic, we're really taking a complete perspective. We're looking at the overall application configuration. We're trying to derive a sort of optimized representation of that configuration. This is basically it is in this case generated source code, but it's a representation that is derived from your application artifact. It's generated. It avoids annotation lookups as far as possible. It avoids reflective discovery as far as possible. So there might be a few tweaks you can still do to optimize the outcome, but fundamentally, we take an existing Spring-based application of a certain kind, at least, as an input, and we produce a sort of optimized outcome that can be used as a deployment unit, trading off between the extra build time effort that you're applying, but getting less work to be done at runtime on startup, and also less infrastructure having to be loaded at runtime. This is the infrastructure notion is actually pretty important here. If you're not parsing any XML files, then it doesn't have to be an XML parser in the runtime footprint. Not in the disk footprint, not in the memory footprint. The same applies to other facilities. You can find this in kind of its hardest fashion, with the hardest constraints, when trying to build a native executable, but you'll already get the same kind of effect even with a regular hotspot JVM deployment. Along with this goes this notion of runtime hints that you might see reappearing. The runtime hints are, for a regular hotspot JVM, not essential to be present. On startup, they are kind of something that we derive at build time, and in producing a deployment unit, we can take them into account. For a native executable, they're a must-have. If you're trying to deploy in a form where only specific reflective capabilities, only specific proxy capabilities will be available, will be generated into the image. If that is the case, then they are a necessary part of the story. For the general picture, they can be seen as literally hints, as build time derived information that on startup, the runtime can consume and even optimize itself, pre-warm itself, theoretically at least. That's the model that we're using. This is a pretty flexible arrangement. So as you may infer from the perspective that I'm using here, this is not exclusively designed as input for a native executable at all. It is a very general recipe, a very general principle that we're applying here. So why would you want to do this? Well, I kind of hinted at it already. You're taking an extra build time step, or potentially several, and you're trying to reduce the startup time. You're trying to build a deployment unit which, whenever bootstrapped, happens to have better startup time characteristics. You're also reducing, actually, you might also reduce the disk footprint, but in particular, you're also reducing the memory footprint of your application, which in terms of cloud deployment and cloud scaling may be a huge topic in its own right. Now, would you just use it because you can? Well, in terms of experimentation, for sure. If in your deployment arrangement, startup times don't really have any significance, any real significance, then it might not be for you. But worth experimenting in terms of what difference you get, whether it's applicable to your scenario out of the box, whether you get significant benefits out of the box. I would recommend, as this is maturing as of the GA release, I would recommend giving it a try nonetheless. It is a hard precondition for trying to build a native executable. So that's where it is a mandatory step to take. A specific notion that is also worth highlighting here already. You're not only trading off build time versus runtime, you're also trading off a certain flexibility at runtime. You're kind of locking down, even with general usage of AOT, you're kind of locking down a certain arrangement for your application, a certain configuration arrangement. So if your application happens to be a more like product arrangement that auto-adapts to the target environment that it is deployed to, AOT might not be an ideal fit, at least not in its standard form. You might have to customize it at least. The AOT arrangement makes an assumption that there's many things that you can already predetermine at build time, and they don't have to be flexible at runtime anymore. Again, with GraalVM native executables, that's a sort of must-have assumption to keep in mind, but fundamentally it applies to any use of AOT. Now, in terms of what you might want to do this for, let's start with the optimized JVM deployments. This is not actually asking for a lot of extra overhead at build time. It's a pretty light, in comparison to other things happening at build time in builds, a rather light step to take. A bit longer, you're basically letting the build perform an extra step. It doesn't take that much longer. And you get the benefit of the deployment unit starting up a little more quickly, even with a regular hotspot JVM. Now, this particularly matters if your deployment unit is part of a cloud scaling arrangement where it might be bootstrapped many times, it might be turned down again, it might be rebootstrapped depending on load. So if, in particular for dynamic bootstrapping arrangements, a dynamic lifecycle, dynamic deployment arrangements, that's in particular where these trade-offs shine. Don't just do Spring AOT and leave it at that. If you really care for optimizing your JVM deployment, there's many other, sometimes actually quite a few of those recent JVM features that you can use. So there's many JVM features that go along nicely with Spring AOT. Up until the class data sharing arrangement, there's many things you can do to optimize a JVM deployment arrangement at the JVM level. Spring AOT, this AOT step for a Spring application context, is really meant to add to that, basically, to be a good citizen in an optimized JVM arrangement. Now, the sort of elephant in the AOT room is the GraalVM native executable topic. The assumptions that the native image tool in GraalVM makes, that the native image modeler in GraalVM makes, are really coming down to a very strong so-called closed world assumption, where it's almost a full lockdown of what the system can do, which classes it can load, which files it may ever access. It's kind of a not very JVM-like mentality to apply. It's more of a traditional installation perspective. You're really trying to lock down as much as possible. You have to for a native executable. Spring AOT does the lion's share of that work for you for a given Spring application as input. And then you feed the outcome into the GraalVM native image tool. And what you get, if everything works fine, is a native executable as output, that does exactly what you asked for. No more. So this is not about flexibility in this executable. It's about pinpointing a specific arrangement and generating an optimized native executable for it. There's also other trade-offs involved, but those are a little in flux with the evolution of GraalVM itself. A native executable, for example, is by no means as runtime adaptable as a hotspot JVM. The hotspot JVM is really good at adapting to peak scenarios, to runtime optimizations of hot code paths. A native executable doesn't really do anything at that level. It really tries to optimize as much as possible at build time. So you're also trading off a certain degree of runtime adaptability to runtime load, a certain degree of peak performance. You're trading that off for other characteristics, such as a lower memory footprint and immediate startup. So there's a bit of a trade-off involved, as with everything, right? In our space, there's always a trade-off involved, and here it's about flexibility and peak performance versus startup time and memory footprint. The build time step, the actual native image generation step, can take very long and burn a lot of CPU time. So it's also not a light step to take. You won't be doing this in your regular development cycle. You'll be doing this in specific build arrangements and specific deployment arrangements. It's a much tougher pill to swallow than optimizing for a JVM, a hotspot JVM arrangement. Now, this is actually not the end of the perspective. As a recent comer up again, we have an OpenJDK project called Laden. It's been announced quite a while ago already, but recently concrete steps are being taken towards initial goals for this project. This is an OpenJDK project, so it's fundamentally based on the hotspot JVM and the standard JVM arrangement with the tools around that you typically use, like class data sharing, JLink, all of those tools would come back into the picture as a starting point. This is about different features that can be combined towards not only an optimized hotspot-based deployment arrangement, but a custom arrangement. It's a bit of a different philosophy even here. What is being called a static image here is basically a runtime variant of OpenJDK that is designed for running a specific application only. So there's just like with AOT in general, there's a specific application as input, and you would generate or build or customize, configure a specific OpenJDK deployment to be optimized for that specific application, and in terms of its footprint, in terms of what it's actually capable of doing, it's minimized towards being able to run that application and that application only. The intentions behind Project Laden are meant to apply an incremental approach. So the idea is that you can choose different constraints, different levels of constraints, and you get different impact, corresponding impact in terms of runtime flexibility out of it. So it's not necessarily an all or nothing or a standard hotspot deployment versus native executable. It's the space in between. It's sort of all the options, all the tuning options, all the trade-offs you can make in between. With native executables being sort of the end of a spectrum with their very strict closed world constraints and different degrees of flexibility versus footprint to be found in between. Incremental also means that we can expect Project Laden inspired features to be coming in several JDK releases. The JDK releases twice a year, so there might be, say, a first Laden feature coming in JDK 20 or 21, and further features that kind of really add up to the full picture, to the full story, then coming in JDK 2020, 23, 22, 23, and so forth, right? So it's very much also an incremental delivery that we can expect here. This is as far as we can tell right now, from this kind of strategy statement that got recently published for Project Leyden, is very much following the same philosophy as Spring AOT. Spring AOT is also meant to be flexible, customizable, allowing different levels of trade-offs. Eventually, we're not necessarily talking about Spring AOT as it is in the 6.0 release. We're talking about Spring AOT as it will evolve over the 6.x generation. Just as Project Leyden will release its features in JDK releases over the next few years, Spring AOT and Spring Framework in general, Spring Boot in general, will be able to align and catch up with the way that Leyden is going over those same next few years in our own feature releases. All right, so much for AOT, and you'll find plenty of other good stuff, and in particular, more like demo-oriented stuff in other sessions at this conference. Let's switch topics to the aforementioned module system. The module system in Java is a bit of a, it's a bit of in a strange position. If you look at the wider Java ecosystem, the wider landscape, the module system is not necessarily broadly adopted as a first-class mechanism in the Java ecosystem. Most libraries, most applications are designed for the class path, for standard Java deployment on the class path. They're not really, other than assigning a module name, an automatic module name in the manifest, they're not really doing anything too specific for the module system. The module system, of course, is used by the JVM internally, so you're actually running on the module system in any case. The class path is the unnamed module, a single large module that runs within the module system next to the system modules of your JVM. That is the case since JDK 9. What I really mean as a differentiating factor here is whether the application, or also to some degree the framework and the libraries, whether they have more than this, whether they support first-class usage of the module system, where you're actually composing your application deployment units as modules with module info files, referring to the framework APIs and the library APIs that you integrate with through module declarations. A module info file, a module info Java file, is basically just the combination of a module name with dependency declarations, which other modules do you require to be present, and potentially also with exports declarations in terms of what kind of visibility, which parts of your module are supposed to be visible to other modules. There's quite a bit of power in what a module descriptor like module info can do, and nothing really prevents you from exploring some of these features in the module system. Even right now, you can do this with Spring 5. We ship automatic module names, we have well-known module names, but there is a limitation. There are a few limitations. For a start, the framework modules don't ship module info files. They only suggest a module name, so we don't have requires clauses, basically. So whenever you require spring.context, there's no information for the module system that there are transitive dependencies like Spring Beans or Spring Core for it. You have to name them as you need them. If some of the APIs are also in use from there, which is certainly the case with Spring Context, which brings together Core, Beans, AOP. The benefit of us starting to ship module info descriptors in our framework jars is basically this. The requires clauses for transitive dependencies become optional then. We would provide information to the module system that allows the module system to derive the transitive dependencies just from the Spring Context clause. The module info file for Spring Context would internally say require Spring Beans, and we go from there. This is what we are having in consideration for Spring 6. For Spring 6, it's not actually in a milestone yet. We are still exploring a few side effects module info shipping. This is not as trivial an exercise as it may seem initially. There's a notion I haven't mentioned yet, optional dependencies. One thing that complicates this a lot is that the Spring Framework modules can integrate with third-party dependencies on an optional basis a lot. Think about a Spring Web, for example, with all of its message converters. There's many others. Spring ORM being able to run with Hibernate, with Hibernate native APIs, or just with JPA. Everything is optional until you start using it. This sort of arrangement is not very first class in the module system. We can express it, we can arrange ourselves for it. To some degree, it makes the module system a little less compelling for us as framework providers if there's plenty of optional dependencies to deal with. Nonetheless, it's still on the 6.0 roadmap. If you have a strong interest with it, in that area or just experience with it against Spring 5, we would certainly love to hear about it, because fundamentally, we're not trying to do something just because it's technically possible. We're trying to improve what you can do in your applications in combination with Spring jars, so what a Spring-based application can do when it opts into the module system. Architecturally, you choose to use the module system, you choose to build a Spring-based application for it. We're trying to make your job as smooth as possible. Everything that works towards that purpose is worth considering for this infrastructure theme in Spring Framework 6. Another part of the module system story is the JLink tool, where you may, even with a regular JVM over the past few years, you may build a JVM runtime image that contains certain modules only. You bake those into a representation that the JVM bootstraps with. This can be used just to shrink the size of your JVM arrangement a little. It can also be used for more custom purposes than this. At the moment, we're not really participating in such an arrangement. Automatic modules can't be considered by JLink. Once you have, those are modules just with a module name. So basically what we ship now, Spring 5 has automatic modules. In Spring 6, with the inclusion of module info as proposed, we would be able to participate in JLink images. But just because it's technically possible doesn't mean we actively recommend it. We actually see this distinction between the JVM image and the framework jars on top as a worthwhile distinction. We're not necessarily expecting framework jars to be embedded in JLink produced images with this model. You know, whatever comes out of other themes and other efforts, but within the standard module system, we have yet to see a strong demand for embedding Spring Framework modules into a JLink image. If that's something you consider doing, it's also worth letting us know. It's in consideration. It would implicitly be possible just by us shipping module info descriptors. A related topic is the size of that generated runtime image. If you're using JLink, you basically can only exclude a standard JVM system module if it's not used anywhere at all anymore. And there's a couple of modules that just are commonly coming up as a sort of minor dependency of some frameworks or libraries that you might be using. So there's plenty of them, but a specific case worth exploring here is the java.beans package. Very commonly used also in Spring and in many other open source projects actually still. There's the Java Beans introspector, the Java Beans property descriptor arrangement, everything that has to do with the introspection of classes that follow the Java Beans conventions. And even if it's just a single place in an application where such an arrangement is being used, or a single framework module or library module in use that transitively uses java.beans, you will have to have it in your runtime image. Unfortunately, in the standard OpenJDK module arrangement, the java.beans package lives in the java.desktop module out of a little bit of history and a few interdependencies with AWT. This is a bit unfortunate. The java.desktop module isn't generally necessary for server-side applications. It doesn't hurt, but it's just not a very obvious part of a server-side application otherwise. So the continued use of the java.beans facilities requires J-Link-produced image to include the java.desktop module, which to some degree leads to a suboptimal outcome. Now, whether that is a huge issue or not is also related to other efforts going on, right? If we're producing, with Project Layton, if we're producing specific static images for a specific application, this might not actually work with module boundaries. It might transitively include the bytecode of the types that are actually reached, ignoring module boundaries. Then some of this problem would disappear. But with the standard J-Link arrangement, which only works with module boundaries, java.desktop can only be in the image in its entirety or not at all. There is a problem that can only be solved through getting rid of any use of java.beans. We haven't acted on that yet. We haven't even made a decision yet, because quite a few third-party libraries that are commonly used in Spring applications also use java.beans. If we get rid of java.beans usage, that doesn't help at all if common other frameworks or libraries still use it. What would we have to do? We would have to replace the JavaBeans introspection and the JavaBeans property descriptor arrangement with basically a custom arrangement that we could tailor for our purposes, but fundamentally uses the same conventions for setter, getter, methods, and so forth. To some degree, we would have to implement an equivalent arrangement in our own Spring Core module. We are still wondering whether the effort and the compatibility impact, the backwards compatibility impact of that is worth the benefits, since we have yet to see much use of J-Link, really. So that's why, again, a call out, if you're a stakeholder in J-Link, if you're using this, if you're using images and you'd like to get rid of the java.desktop module, let us know. Last but not least, for the module system, before we move on to a few notes on virtual threads, the module system also has a couple of interesting facilities. If code lives within a module, if an application deployment unit is built as a module, there are certain facilities, certain module APIs that we can use to introspect that module at runtime. And there's also a few side effects from that. So what we are finding in Spring 5 is that our standard class path scanning arrangement works with modules in general, but the moment that you start using a feature that is called patched modules, module patching, the moment that you start using this, we are not seeing the complete picture in our class path scan. There might be types that we're not seeing, that we're not scanning, that we then also can't register, that came in through the patch. Now, patching is actually used for some purposes implicitly. The Maven Surefire takes an application module and patches the corresponding test classes into it. So there are certain scenarios where this is already an issue. This recently made it into the mainline in Spring Framework 6. We are using the module reader API if we're within a module to see a complete picture of the module contents instead of a class path scan. This is basically an automatically available feature. If you choose to use within the to run within the module system, if you choose to use the module system for your application deployment units, we auto-detect that and automatically use the module reader API to see the full contents of your module. So the module system story in Spring Framework 6 has several rather independent features, actually, rather independent steps that we can or cannot take. This is one we've already taken. For the aforementioned ones, to some degree, we're still exploring the impact. We're trying to wrap up the module system story for Spring Framework 6.0. So we basically know where we are, we know the constraints, we know the trade-offs. Whether or not we take certain steps will have to be decided in time for the 6.0 GA release, and is then basically part of the generation definition for the Spring Framework 6 line. Now, let's talk about virtual threads just a little bit more. We have already explored a little bit of it this morning. Project Loom goes into preview as of JDK 19. This means that with -- enable preview for your compiler and for your runtime bootstrapping, you can unlock this preview feature and even start using it. It's just not meant to be a production feature quite yet. Virtual threads, I've already mentioned this morning, are a lightweight threading model within the JVM. The idea is that the operating system thread is basically a carrier thread for potentially several virtual threads. The moment that a virtual thread blocks, based on typically an I/O operation, it would implicitly release the carrier thread, which is then available to take other virtual threads forward in the meantime until the original thread comes back and then gets reassigned, repinned to a carrier thread. So it's basically an arrangement where with a limited number of operating system threads, you can set up a potentially very large number of virtual threads that have to pay no respect, no specific attention to blocking. So it's not a barrier anymore to use imperative programming, say, in a servlet MVC handler method arrangement. It's not a showstopper anymore to have database interactions or calls to other services in a microservice architecture. If those are blocking, they are not blocking an operating system thread anymore, ideally. You can set up your servlet container potentially with a very large number of application callback threads. Depending on your scalability needs, this may be quite a game changer in the trade-offs that you can make. So it's certainly true that this gives kind of a new light and a new scalability perspective to imperative programming. At the same time, it has no other basically extra features. It is exactly that. It is exactly a virtual threading, JVM managed threading arrangement. Whereas with reactive programming, you might also get some of these scalability benefits, but you also get a different programming paradigm. The attractiveness of virtual threads is primarily to keep using an imperative programming arrangement, or to take an existing application that is programmed with, designed with, within the imperative programming model, to take that existing application and with a little bit of tweaking and a little bit of setup, unlock a scalability potential that wasn't there before. So in the details, there's quite a bit required in order for that to work at runtime. Many of the JDK libraries, both file access, networking, and general thread handling, are all designed to participate in this model. So they automatically release the carrier thread when they hit a blocking point. But there's limitations. For example, if you use a synchronized block and you trigger an I/O operation within a synchronized block, the JVM can't release the carrier thread. So you're still pinned to the operating system thread. You're effectively blocking the operating system thread. So I/O operations need to happen outside of synchronized blocks or with other means of locking. Java util locks, reentrant locks, and so forth are all designed to participate in the Loom-friendly by default. Synchronization standard, keyword-driven synchronization isn't. Now, this is, of course, does not only affect your code. In particular, it affects all the infrastructure code out there. The HTTP engine implementations, JDBC driver implementations, all of those need to adhere to those principles. No I/O operations within synchronized blocks, so to some degree re-architecting some synchronization in some areas possibly. And of course also providing setup options for virtual threads for a start. Virtual threads are not exactly just another variant of a thread, they are a little special. You're creating them on the fly for every task. There's no need to pull them. It's actually, you should not pull them. Let's phrase it a little more strongly. Just freshly create a virtual thread for every potentially blocking task. So that requires, in some cases, not only an option for a Tomcat thread pool that just uses virtual threads, it sometimes requires a little more re-architecting if if it's a thread pool initially, you might want to turn this into an executor that can pool but doesn't have to pool. Maybe uses some other kind of concurrency limiting so that you are not going to excessively create virtual threads, because a thread pool is also kind of constraining the concurrency in the system, the overall concurrency. With virtual threads, maybe you're going to use another kind of limiter there. There will be quite a bit of effort, hopefully a coordinated effort for Loom friendliness, for Loom compatibility in the wider ecosystem. We are trying to roll as much as possible from our end, also from our influence sphere, so Tomcat and so forth. We're trying to get as much of this into releases that will be available in the November timeframe, so that when you have the JDK 19 Loom preview to experiment with, that the then current Spring Tomcat, Spring Framework Tomcat and Spring Boot releases would allow you to explore the potential of virtual threads by certain steps that we've taken internally, certain refactorings maybe, in particular also by some setup guidelines that we would be providing to easily get started with a virtual thread setup. All right, I was already mentioning Tomcat and Jetty as a main target. Web applications with their typical callbacks to MVC handler methods, to servlet methods, operating with input streams, output streams, potentially blocking for many reasons, typically database bound. There's a significant scalability benefit to be expected for such applications, and those are the primary targets. The other area that we're exploring is messaging and scheduling still. It's a little different there. Lots of those callbacks do mostly CPU-bound operations. They wouldn't benefit from virtual threads. You're only really going to benefit if otherwise the threads would block on I/O operations. So there might be some side benefits, or maybe even some major benefits for certain messaging-based systems as well. That's another angle that we're exploring. All right, and this is just a call out to the same other features that I raised this morning. Keep in mind what I've been talking about here is a selection of specific infrastructure topics. There's plenty of other Spring Framework 6 and Spring Boot 3 goodness explored at this conference. For example, the declarative HTTP interface clients. And related projects, other projects such as Spring GraphQL, for example. All right. Once a reminder, we're working towards a November 2022 delivery, and we are currently at the milestone 4 level. We expect a release candidate 1 in October. We expect the GA release to follow, maybe after one more release candidate in our November release train, just in time for the Spring Boot 3.0 GA release. So in case you've been wondering, those are very closely aligned. Spring Framework 6.0 and Spring Boot 3.0 are meant to go generally available in the same release train mid-November. All right, then so far, thanks for your attention. This is all the ground I'm meant to cover in this specific session. Enjoy the rest of the conference, enjoy the Spring Framework 6 related content, and of course also all the rest of the good stuff covered here. If there are any questions, I'm around right after this talk if you'd like to have a conversation, or just catch me at the conference in the hallway, or just raise any concerns or any input that you have through our usual channels, be it GitHub, be it Twitter, be it elsewhere. Thank you.